can you start by telling us your name, role, and institution?
Yeah, my name is Mei He. I'm an associate professor from the University of Florida College of Pharmacy. So I'm working on this project and with SCGE and as the leading PI to work on the U1 project.
Great. And then can you provide a brief overview of your SCGE project?
Yeah, this SCGE project actually mainly focused on the extracellular vesicles that used for genome editing delivery approach. So extracellular vesicles have been emergent delivery carriers, and they are naturally secreted from the cells. So have a very super biocompatibility and a tissue penetration ability. However, for using the extracellular vesicle to load the genome editors and as the cargo loading, it's very challenging. And so far, there's no any like a GMP compatible on a larger scale approach for loading the genome editors into the extracellular vesicles. So that's our U1 project step in to solve this grand challenge and develop the platform and which be able to have the very high efficient loading of a genome editor into the extracellular vesicles and compatible with GMP and larger scale production. So this U1 project actually we're focused on the couple aims and including the GMP production, the validation of this platform, and producing the CMC data, and also to study the genome editing, especially CRISPR editors loaded extracellular vesicles for toxicological study, and to make the documentation package ready and for the IND filing. So that we can use this platform for all different kinds of genome editors and loading using the extracellular vesicles. That we hope to collaborate and work with other SCG consortium PIs and to help their project as well.
Great, thank you. So at a high level, how does your high throughput EV loading platform improve the delivery of genome editors?
Yeah, so this platform that enables the extracellular vesicle be able to load large cargoes and in a much higher loading capacity. So our platform focuses on the microfluidic droplet-based electroporation. So this can provide very uniform electric field at low voltage and without damage the extracellular vesicle surface property meanwhile enhance the loading electroporation process and make it much more efficient. So that we prove that for CRISPR RNP complex, we have much higher loading capacity and loaded into the EVs. And then meanwhile, the natural membrane integration of the membrane structure has been maintained really well and still make the EV be able to maintain intact and the natural bilipid membrane structure for the tissue penetration. So they perform really well in the in vivo system and for the tissue penetration. So we had one demonstration that is showing the high tissue penetration getting to the inner ear tissue through this CRISPR loaded EVs and for gene editing.
In your SCG project, your team is evaluating your EV platform in treating hearing loss for IND submission. Beyond
Mm-hmm.
hearing loss, what other diseases or conditions could benefit from this technology in the future?
Yes, we hope the extracellular vesicle that bring the new modality for the gene delivery. So because this extracellular vesicle showed a great tissue penetration and especially it didn't have any immunogenicity or toxicological concern. So compared to the lipid nanoparticle, the EVs can penetrate better to cross the biological barrier and for the tissue penetration. And also compared to other conventional AAV-based gene delivery, the EV actually doesn't show any toxicity in the tissue. So they often had a concern for the AAV-based gene delivery. So that's how our approach actually bring this new modality and overcome the challenges and the concerns from those traditional gene delivery approach. So we hope our new modality be able to cross-board for handling all different kinds of genes and to load, for example, siRNA, the mRNA, the CRISPR, RNP complex, or even the plasmid or other small molecules that we can utilize to have our platform for loading into the EVs and then for delivery in the in vivo to develop their better in vivo gene editing efficacy.
Gene therapy research is a collaborative, interdisciplinary effort. What different skill sets and scientific backgrounds did you need to build your project team?
Yeah, I really like to work with all other project PIs and try to see how our new modality and platform could advance their gene editing or gene therapy development. We talked to a couple research in their project as well, and to extend the collaboration. And the ultimate goal is still want to have their project, including our approach, moving to the FDA approval. So we hope we can really bring the effective gene editing or the gene therapy method from the research laboratory to the patient bedside. So there's a big gap that we need to go through this FDA and the documentation process. So that's the expertise I kind of start to learn. And the SDG consortium actually provide a lot of supporting resources, and then they pair with the groups and often have the workshop for going this process. So that's the really expertise I'm needing, and for moving our platform into the patient bedside.
Great. And then kind of switching gears a little bit. In the next 10 years, what is something that you predict or hope will happen in the gene therapy field?
Yeah, I think there are many gene therapy approach eventually will be approved by the FDA very soon. So that really makes the disease treatment to a new level. Because the most disease treatment, they couldn't guarantee that 100% cure. But with gene therapy, they really make it could happen in the next 10 years. And a lot of disease we can hoping to have 100% cure, and that's the best news to the patients.